Graph the solution sets for the following inequalities, and then write the solution as an inequality without absolute value bars. Recall that the definition of absolute value is distance from zero. So in our first example, we want the distance from zero to be greater than 4. On a number line, here's 0 in the middle, and then the distance that is more than 4 units away from 0 would be starting at 4 and going to the right. This red region is all a distance of more than 4 units away from 0. Also, on the left side, looking at -4 and going to the left. Everything in this red region is also a distance of more than 4 units away from 0. Then if we translate those back into inequalities, the one on the left is x is less than -4, and then the inequality on the right is x is greater than +4. Notice that when the absolute value is greater than a constant, we split it into 2 separate inequalities. In the next example, we're looking at the absolute value of x is less than 4. So again, we're still focusing on -4 and +4 and 0, but this time we want the distance from 0 to be less than 4 units. So that's going to be everything between -4 and 4. Everything in that red region now is fewer or less than 4 units away from 0. To write this now as an inequality without absolute value bars, we actually have a compound inequality. We have -4 is less than x is less than +4. So whenever the absolute value is less than the positive constant, we can create a compound inequality. Back here, again, the absolute value is greater than the constant. Here we have to separate it into 2 separate inequalities. We'll use this concept when we solve inequalities in the next video.